All right, hello, new unit, and it's about ratios. And so I'm kind of putting two easy concepts together because I know you'll do well. And so just a heads up, a ratio can be expressed as a colon, a fraction, or using the word to. So that's our first objective. A colon can be written as, a ratio. A ratio can be written as a colon, a fraction, or using the word to in the middle. And then our second concept, I know you'll do really well. Can two ratios be equivalent? Or how do I know if two ratios are equivalent? Okay, I can compare two ratios to see if they're equivalent. The recipe calls for 3 cups of juice for every 2 cups of frozen fruits. That would make a good slushy, right? And so that ratio can be written with a colon in the middle. It can look like a fraction or the little word to in the middle. All 3 ways are appropriate ways of expressing a ratio. So next example, there were 5 adults for every 15 youth at the swimming pool. So let's just practice writing it. You could say 5 to 15 with a colon in the middle. 5 to 15, and it looks like a fraction. Or just put that little word to in the middle. All right, if two ratios are equivalent, you're going to work then at, we kind of did this already, but you're going to take the cross numbers and multiply. Now notice there isn't an equal sign in the middle, but now take your calculator. 8 times 12 is 96. So 8 times 12 is 96. 11 times 7, 77. So we would say they are not equivalent. They're not equal. Okay, next one. 5 times 45. 5 times 45 is 225. 9 times 25 is 225. And so we would say those two proportions are equivalent. Now, some of you smarties are already looking and saying, well, I can reduce that as 1 to 5, and I can reduce this one as 1 to 5. So you could have just looked at it that way and said, I already know they're equivalent without multiplying. And either way works. It would get a little bit awkward here because 8 divided by 11 was an awkward decimal. Oh yeah, look at, oh, that's a fun one. It's a repeating 0.72, or 7 divided by 12 is well, the 3 repeats, but right now just the 5/8. And so if you change them both to decimals, you'd say, yep, they're not equivalent. But when they're awkward like this one on the left, I would do the cross products and multiply, unless it's really obvious to you. Okay. All right, here's how to do it in a word problem. Ed put 3 cedar blocks for every 5 oak pieces. So 3 to 5. And because they're really written in one sentence, you're hearing that as a ratio. Tad put 9 cedar blocks for every 15 oak pieces. And so here, this next one, that's why I highlighted it all in green. That's one ratio in a sentence. So that's how you know which numbers go together. I would almost always put whatever number comes first in the numerator. So 3 to 5 is your ratio, and put 3 in the numerator, 5 in the denominator. 9 to 15, 9 comes first, so put that in the numerator. And then to see if they're equivalent, just like we did before, crisscross multiply. 3 times 15 is 45. 9 times 5 is 45. So they are equivalent. All right. Some of you are even looking at this and saying, did it proportionally multiply times 3? 3 times 3 is 9. 5 times 3 is 15. So you could have looked at that and said it was proportional or equivalent also. Okay, I'm almost done. Kim put 4 cups of raisins for every 1.5 cups of chocolate chips in her trail mix. Hear that as a ratio, and hear that the first one, whatever comes first goes in the numerator. So 4 to every 1.5. Alan put 3 cups of raisins to every 1 cup of chocolate chips. Are the ratios proportional? Or I'm sorry, equivalent? Proportional is another day, but equivalent, you'd say 4 times 1 is 4. 1.5 times 3 is 4.5. So the proportions are not equivalent. I think that's my last slide, guys. Okay, yes, that's my last slide. So guys, we're gonna work on some IXL practice, and I hope that concept made sense. Please just ask if you need any help. Thanks.